So today you're going to learn how to graph inequalities and then how to write inequalities given graphs or given real world situations. Our biggest difference between inequalities and equations, so we just got done talking about equations, now we're getting into inequalities. So inequalities are similar to equations, but instead of using an equal sign, it's going to use a less than sign, or it's going to use a greater than sign, or less than or equal to, or greater than or equal to. So this chart at the top kind of summarizes all the different inequality symbols that you will see. Whenever you see a less than symbol or a greater than symbol, if you graph it, you're going to have to make sure that you use an open dot. And so we just draw an open dot similar to what you see right here. So it's just an open dot. And then I also in this chart included how to say it. So just as a reminder, this symbol is, you say it as less than, and then this symbol you say it as greater than, and then if there's the little line underneath it like these bottom two symbols, you just add or equal to with it when you say your inequality. A couple key phrases that we use to represent these inequalities are also included. So for this first one, you have less than, and if you're talking about less than something, typically they will say fewer than, or if it's below something, if I say it's the temperature's below 40 degrees, then you would know that it's less than. Okay, another symbol we see is greater than. Anytime it's greater than, they would say that it's more than, or they might say the temperature is above 30 degrees, and then you know it was greater than. Okay, another inequality we see quite a bit is less than or equal to, and that symbol's key phrases are at most or no more than. So if you can spend at most $30, then you can spend less than $30 or equal to $30. You just cannot spend more than that. So less than or equal to would be the symbol you want to use for that. And then lastly, we have greater than or equal to, and the phrases that typically represent greater than or equal to are whenever you see at least or whenever you see no less than. So if they say you have to spend at least $50 to get free shipping, it means you could spend equal to $50 or you could spend more than $50, but you can't spend anything smaller than $50. Okay, and we'll get into how to write those inequalities. Again, this chart up top helps you decide what kind of a dot goes on your graph. So when I say graph this inequality, I'm going to give you the inequality. In this case, your inequality is y is less than or equal to -1. And then on this graph right here, I need you to represent all the numbers or all the solutions to this inequality. And to do that, you're going to color in all the numbers that are less than or equal to 1. So let's remind us right here that this symbol, that symbol means less than or equal to. Okay, so that means that the answer to that inequality, the value that you're plugging in for y, could be any number that is smaller than 1, or it could also be, that's smaller than -1, or it could also be equal to -1. So as you can see in your chart up top, the symbol less than or equal to uses a closed circle. So what you're going to do is on the number -1, you're going to put a closed circle on that number. And then again, it's all the values. So this missing value right here, these are all the values that are less than or equal to -1. So if I want all the numbers that are smaller than -1, I want to color my graph to the left. So go ahead and shade your graph to the left. Okay, and then when you're done with your shading, always put an arrow at the end just to show that if your graph, if your number line were bigger, your equation or your inequality would keep going. It would keep coloring in. Okay. All right, let's try another one. So for this one, graph the inequality t is greater than 2. So again, I need you to graph every value that is bigger than 2. And let's remind ourselves that this symbol right here with the t is greater than. So let's put greater than. And I need us to graph all the numbers that are greater than 2. And again, use this chart up top to see that when you see the greater than symbol, you're going to use an open dot, because if the number has to be bigger than 2, it cannot be equal to 2. 2 is not bigger than 2. So I need a number that is greater than 2. So let's put an open circle on 2. and then let's shade. If I need all numbers bigger than 2, I'm going to shade over to the right. So let's shade it to the right. And then as always, put your arrows at the end just to show that your number line would keep going if it could. Okay, let's go to the next page and try to graph some more of these ones. So like example 5, it's y is greater than or equal to 2. So I need us to color in all the values. Sorry, that's less than. I need you to color in all the values that are less than or equal to 2. So if it could be equal to 2, then I need you to color in the 2. And then I need less than. So this symbol right here is less than or equal to. So if I want you to tell me all the values that are less than or equal to 2, that means it could include 2 because of the equal to sign. And typically what I do is I use this little line as a reminder to color in my circle on the number. Okay, and then it could be anything that's less than or equal to 2. So I need less than. The numbers less than 2 are over here. So there's my coloring in, and I'm going to put arrows at the end to show that my number line would keep going. Okay. One trick that I like to use when I'm doing these inequalities, and I can show you this one as an example, is if you notice your inequality, if your variable comes first right here, then this inequality in the middle, you can kind of look at that as an arrow. So do you guys see how this is kind of pointing that way? You can use this as an arrow that points in the direction that you need to shade. So I know that this inequality is going to be shaded to the left, which on my graph, I shaded it to the left. So I know that that's correct. Okay, so you can use that arrow trick, and let's write this up at the top of the second page. When you're graphing inequalities, you can use the arrow trick as long as the variable is on the left. Or sometimes we like to say it as long as the variable comes first. Okay, so as long as you start with the variable, you're allowed to use that arrow trick. So think of that inequality as an arrow, and it will point in the direction that you need to shade. Okay, let's try number 6. So 6g is greater than -4. So I need all numbers that are bigger than -4, but notice this one does not have the equal to sign below it, so do not color it in. So give me an open circle on -4, and then notice the variable comes first, so I can use my arrow trick. So let's turn this guy into an arrow. Notice your arrow is pointing to the right, so then on my number line, I'm going to shade to the right. Nope, let's go this. Okay, so my number line, let's shade all the way to the right. So I need all numbers that are greater than -4, so I need an open circle on -4 and then shade it to the right. All right, go ahead and try number 7. Number 7, when you graph this one, are you going to do an open circle or closed circle? In which direction are you shading? All right, so for number 7, it's h is greater than or equal to 0 because it has this little equal to sign. That's my reminder that I got to color it in. So I need a closed circle on 0 because it could be greater than 0 or it could be equal to 0. And then if I want all numbers greater than 0, I'm going to color it this way. So color it this way, and then as always, put your arrows at the end to show that it would keep going. And you can use your arrow trick for this one. And it's pointing to the right. And when I colored mine in, mine is also pointing to the right. All right, so please make sure your graph looks like this. I need a closed circle on 0, shaded to the right. Okay, some of your inequalities will not have the variable coming first. So like example 8, this one says 3 is less than x. If the variable does not come first, I would always rewrite it. Or if the variable is not on the left, however you want to think about it, I would always rewrite it so that the variable is on the left-hand side. So let's draw an arrow to show that we're flipping it. If you flip the x and the 3, so I just took this 3 and this x and I just flipped spots. So now the x is on that side, the 3 is on that side. So if you're going to flip the 3 and the x, then this inequality right here in the middle also needs to be flipped. Right now it's less than, I need to flip it so it is greater than. So now instead of graphing 3 is less than x, I'm graphing x is greater than 3. And that's these two answers, these here, are the exact same thing. Okay, but with this answer, I'm able to use my arrow trick to help me with my shading. Okay, so there is no open line underneath it, underneath this inequality. So I'm going to do an open circle on 3. And then again, the reason we put the variable on the left-hand side is so we could use our arrow trick if we wanted to. It's pointing to the right. Or if you just say this inequality, x is greater than 3, I need all numbers that are bigger than 3. So I want to go to the right. Greater than is on the right-hand side. Okay, and then put an arrow to show me that it would keep going. All right, let's try number 9. So for number 9, please switch the way it's written. So flip the way it's written, but when you flip the way it's written, also flip the inequality in the middle. And then go ahead and graph number 9 and explain your graph to me. Is it an open circle or closed? And then are you shading to the left or to the right? All right, so for number 9, again, you need to flip this so that our variable is on the left-hand side. Just like with equations, typically our variable is on the left-hand side. Inequalities is the same thing. So if you're going to flip the w and the 4, you also have to flip this guy in the middle. Right now it's greater than or equal to, so I'm going to flip it so it's less than or equal to. I like to use this equal to symbol as a reminder that I need to color in my 4. So go to 4, color it in. So I need a closed circle on 4. And then the reason we flipped it is that we can use our arrow trick. Our arrow's pointing to the left, so I need to shade to the left. Or if you just say it, you would say it as w is less than or equal to 4. So the value that we could plug in our inequality here, the value that we could plug in for w can be any number that is smaller than 4 or equal to 4. So it could be any of these numbers that you see right here. Or if our number line kept going, it could be anything past the -5 or smaller than the -5 as well. So closed circle on 4, shaded to the left. All right, and the last one I want you to try. So 0 is greater than z. Let's rewrite it and then graph it. All right, so when we rewrite it, we flip it. Variable needs to be on the left. So flip your z and your 0, which means you have to flip the inequality. It was greater than, it is now less than. Remember, if there is no line underneath it, do not color it in. So I need an open circle on 0 because I specifically need all numbers that are less than 0. If it's got to be less than 0, it cannot be equal to 0. It has to be smaller than 0. So if I want all numbers less than 0, I'm going to color it to the left, and you can use your arrow trick to remind you that we're shading to the left. All right, so let's try something different. So these ones, we were given an inequality and we graphed it. Now let's try, I'm going to give you a graph, and you have to tell me what would the inequality be for that graph. And you can use any letter you want to. I'm always going to use an X just to be consistent, but you can use whatever letter you want to. And we can still use this symbols chart to help us remember what our different symbols mean. If you look at this number line right here, notice that this 7 is colored in, and then they're shading to the left. So if you look at the 7, they're shading the 7 and all numbers that are smaller than 7. So these values right here, all these values that they shaded in for us, these values, so the values are x, okay, it could be any of these numbers that they have shaded in for us, so we can just represent it using the letter x. It includes the 7, so let's put an equal to sign below it, and then they're shading in all numbers that are 7 and less. Like all these numbers that they're shading in right here are smaller than 7, so less than or equal to 7. Okay, and if you want to kind of use your arrow trick but backwards, you can do that when you're writing inequalities. So if you notice that on this number line they're shading to the left, then make your inequality point to the left, and that way you know that your inequality is correct. Okay, so for this one, the values that we could choose for this inequality, you could choose any of these numbers that are less than or equal, because it's colored in, less than or equal to 7. Okay, let's try some more. So these examples right here. And again, I'm going to keep using x's just to be consistent. You can use any letter you want to, but I'm going to say x. And then again, if you want to go ahead and just use your arrow trick, go ahead. So notice how this graph, it's colored in, so I know it's about to have an equal to sign with it. And then it's pointing this way, or it's shaded this way. So I know it's going to be greater than, or if you think about it, all the shading is going to numbers that are 4 and bigger. Like these numbers over here are bigger than 4. So I know it's going to be greater than or equal to 4. Okay, and use that arrow trick to help you out. This number line is being shaded to the right, so make sure your inequality points to the right. Or you can say all these numbers over here are all going to be bigger than 4, so it's greater than or equal to 4. All right, let's try number 2. So for number 2, again, I'm going to use an X. Okay, this is an open circle, so I know it's either going to be greater than or less than, and if you look at where the shading is, they shaded all numbers that are bigger than 0. So the numbers that they're shading are greater than 0. Okay, and again, they're shading to the right. My arrow points to the right, so I know I'm good. All right, so for number 3, go ahead and try this one. Use X for your variable and tell me what would your inequality be for number 3. Okay, so for number 3, again, notice it's an open circle right here, so I know I'm going to have to use greater than or less than. Start with your letter, whatever your letter you want to use. I said use X, so hopefully when you typed in your answer, you used an X. And then just look at what's being shaded here. They're shading all numbers that are smaller or less than -1. So I have X is less than -1. All right, so give me the variable comes first. I need a less than symbol and then -1. And as always, you can go ahead and use this arrow trick to help you make sure you know your inequality is facing the right way. Okay, last one I want you to try is number 4. So again, use X for your variable and tell me what is your inequality going to be for number 4. Okay, so when you do number 4, again, start with your letter. And then I can see that this is colored in, so I know it's going to have an equal to with it because it could be equal to. When it's colored in, it means it could be equal to 2. So here's my 2. And then if you look at what's being shaded, they're shading all numbers that are bigger than 2. So greater than or equal to 2. Use your arrow to double check. This is pointing to the right. My inequality is also pointing to the right. So I know I'm good. X is greater than or equal to 2. Okay, and then last type of thing we're going to do, and this part right here at the top of the second page, this is just a reminder of what's on that first page. So we're going to use an open circle anytime our inequalities are greater than or less than. And then we're going to use a closed circle anytime it's greater than or equal to, less than or equal to. And like I keep saying, I kind of use these equal to, like these lines underneath there, to remind me that I have to close in my circle. I have to color it in. Okay, because these ones means it could be equal to, so it means it could include the number that we're talking about. All right, couple more we're going to try, and this is where I give you a word problem, and you have to make up an inequality for this word problem. Okay, so this first one, it says no more than 150 people can occupy the room. Okay, so we always want to pick a variable and name it. I'm going to say, well, I'll use X, but I'm going to tell you what it stands for. So I'm going to use X every time just so that we're consistent when we write our answers for these next few. So I'm going to say X is my variable, and it stands for the number of people the room can occupy. Okay, so X is the number of people that the room can occupy, and it says it can occupy no more than 150 people. And you can use your chart at the top to help you see which inequality to use where it says no more than. So you can use that chart up there, or what I like to do, because you won't be able to use this chart on a test, what I like to do is I just like to think about it. So if I say, hey, you can invite no more than 150 people to your party, or this room can hold no more than 150 people. That means it could hold 150. Like if I tell you you can invite no more than 150 people to your party, you could invite 150 people, and you could invite less than 150 people, but you could not invite more than 150 people. So it's no more than. So it's got to be less than or equal to 150. Okay, so my inequality is X is less than or equal to 150. And then when we want to graph it, let's just go ahead and throw 150 in the middle of our graph. Okay, and let's just count by 50s and we'll just label a few of these. So this would be like, this is 100, this is a 250. You don't have to label all of it. Usually your number line will be labeled for you. So this would be 50, there's a 0. Okay, so now we have to graph it. So look at your inequality that we just wrote. X is less than or equal to 150. Notice it has the equal to sign. So I know I'm going to color in the 150. So close circle on 150. Let's color it in. So close circle on 150. And then if it's all numbers that are less than or equal to 150, then 150 is the biggest number that I could possibly have, or that room could possibly occupy. 150 is the biggest number, and then that room could have anything less than 150, but it can't have anything more than 150. Okay, let's try some more of these story problems. And again, honestly, since you won't be able to use this table at the top to help you out, I would just try to think, could it be equal to that? Could it be less than that? And could it be more than that? Okay, so like this next example, okay, you can drive at most 35 miles per hour on residential streets. So at most is our key phrase here. Let's underline it. Okay, we're going to name a variable. So you can drive at most 35 miles per hour. So the X that we're using, that would be the speed that you're driving. Or you could put MPH because it's really like the miles per hour that you're able to drive. And if 35 is at most the speed you can go, means could you go equal to 35? Yes. Could you go less than 35 miles per hour in residential streets? Yes. Can you go more than 35 miles per hour? No. So this one is X is less than or equal to 35. So if you can drive at most 35 miles per hour, again, I just like to think of it. Could it be equal to 35? Could it be less than 35? And could it be more than 35? Okay, you can drive equal to the speed limit, that's fine. You can drive less than the speed limit, that's okay, but you can't drive more than the speed limit. All right, let's try our next one. You need to spend a minimum of $15 to use the coupon. Let's take out the word take. All right, minimum is our key word here. You have to spend a minimum of $15. Okay, so let's put X. And this is the money you spend. Okay, so X is how much money you're spending. And if you want to use the coupon, you have to spend a minimum of $15. So if it's a minimum of $15, could you spend $15? Yes, that's the smallest amount you can spend. Could you spend more than $15? Yes, so if you could spend equal to $15, let's put an equal to sign. Okay, could you spend more than $15 and still be able to use your coupon? Yeah, you could spend more than $15. Could you spend less than $15 and still be able to use that coupon? No, if you spend $13 or $10, you won't be able to use the coupon. So in order to use that coupon, you have to spend greater than or equal to $15. All right, let's try one more. I'm going to have you guys try this one on your own. So it says you can invite no more than 5 friends to your sleepover. Okay, so X are friends invited. And you can be as specific as you want. Friends invited to the sleepover, whatever you want to say. All right, so we're going to start with our X and then see if you can figure it out. If I say, or if your parents say, you can spend or you can invite no more than 5 friends to come over for your sleepover, then would it be X is greater than 5, X is less than 5, X is less than or equal to 5, or X is greater than or equal to 5? So go and try that one. What would your inequality be? All right, so as you think through that one, again, I would just ask yourself, could it be equal to 5 friends? Could it be more than 5 friends? And could it be less than 5 friends? So if you can invite no more than 5 friends to your sleepover, you could invite 5 friends. That's okay. Inviting 5 friends would be fine because your parents said no more than 5 friends. So that's okay. You can invite equal to 5 friends. So let's put our equal to sign. Okay, could you invite less than 5 friends? Well, if they said you can invite no more than 5 friends, then you could invite less than 5 friends, so that's okay. And then could you invite more than 5 friends? Well, if they say you can invite no more than 5 friends, then you definitely cannot invite more than 5 friends. So here our inequality would just be x is less than or equal to 5. All right, so please make sure your notes are all filled out. We've gone through all these examples here, and please reference back to them when you are completing your homework. Always look back at these notes because they have some key phrases you might need, or on your homework you will make your own graphs just like we did in these first 2 examples, example 1 and 2 here, and just like we did in these 6 examples here. So there's some examples there on how to create your own graphs. So please reference back to this. This chart at the top is super helpful to know whether it's open circle or closed. And then these hints that we put right here help you decide which way you're supposed to shade when you go to graph these. So please reference back to these anytime you're doing bell work in Class Kick, or anytime you're doing homework or just need some review. Please look back at your notes. That's why we take them. That's why they're there. So please reference back to them and let me know if you have any questions.